This is the 54th video on Newton's laws of motion. This is in continuation of the 53rd video. So in the 53rd video, I took up a numerical problem in which there was variable angle. So the constant relation for displacement, velocity and acceleration were not identical. And that is, the constant relation for acceleration was different from that of displacement and velocity. In this problem also, I'll take up a similar question. Okay. I'll take up a similar question on Newton's laws of motion, in which there are variable angles in course of motion of the system. So the constant relation for velocity and displacement will still be same in format, but the constant relation for velocity and acceleration will not be identical. There will be additional term also. Okay. So to demonstrate this concept, first I'll take up this problem. I'll draw the diagram of the situation. See, the situation is like this. This is a smooth horizontal surface. This is a wedge. This angle is suppose this angle is 60 degree. All right. This is a wedge of mass m. Okay. This is the inclined surface of the wedge. Here there is a massless pulley fixed to this wedge. Here there is a block of mass m. Okay. Here there is a string which passes over this pulley. Okay. And this string then comes here like this, and then like this. See, this initial angle is theta naught. It is given to be 30 degree. So in this, first of all, this is a smooth, there is no friction anywhere. This is a horizontal surface, fixed horizontal surface. This is a wedge of mass 4m which can slide on this horizontal surface. This is the inclined surface of the wedge. This is a block of mass m. It is attached to a massless inextensible string which passes over this pulley and then passes over this pulley. This pulley is fixed to the wall, and this string passes over the pulley and is joined to the wedge at this point. Now there is no friction anywhere, as I've said. String is massless and inextensible. No friction anywhere. System is released from rest. Okay. Question is, find the acceleration of wedge with respect to ground at an instant t seconds after is released from rest. Also find its initial acceleration of wedge. With respect to ground. Okay. So this is the problem. Okay, fine. Now see, when the system is released from rest, this block will slide down the incline because of gravity, and wedge will move rightward. So in course of motion, this theta naught will change with time. This angle will no longer remain 30 degree. It will keep on changing. In fact, this angle will begin to increase. You can see from geometry. This goes down, this moves rightward. So this angle becomes larger, more and more. So this variable angle is there. So now what we have to do, first of all, we have to find the acceleration of wedge with respect to ground at arbitrary instant t after the system is released from rest. So suppose at an arbitrary instant t when the system is released from rest, the situation is something like this. I'll draw the situation diagram here, but it's of smaller size. Okay. So see, this is the wedge. Okay. This is a string here. This is a block here. Like this. This string segment is horizontal. Okay. Suppose at this instant this angle is theta. Now suppose this has an acceleration of b with respect to wedge, and this wedge has an acceleration of a with respect to ground at this instant. Suppose at this instant the velocity of wedge with respect to ground is say v1, and velocity of block with respect to wedge is say v2, and v1 is the velocity of wedge with respect to ground at arbitrary instant small t, and v2 is the velocity of block with respect to wedge at this time instant small t. And suppose in small time interval this wedge gets displaced rightward by dx with respect to ground, and block suppose it moves dl with respect to wedge down the incline. So b, v2, dl all are with respect to wedge, and dx, v1a are all with respect to ground. Okay. So now first what I'll do, I'll draw the free body of this M. Okay. In the frame of wedge. So wedge I'll denote by W. Wedge I'll denote by W, and this block I'll denote by P. Block P. Okay, fine. I'll denote this by some of the symbols, say block B. And this wedge will be denoted by W. And this block will be denoted by B. Okay, fine. So see, first I'll write down the equation of motion of this with respect to wedge down the incline. First I'll draw the free body of this block with respect to wedge. So at this arbitrary instant, not initially but at some arbitrary moment t, this is a situation at time t after the system is released from rest. So what do we say here? So mg, tension T. Also string is massless and there is no friction between string and pulley. So tension at all points of the string is same, equal to say T. So T is the tension at all points of the string. So T acts on this block in this direction. mg is this, normal reaction is here. Now this wedge is a translating non-inertial reference frame. If you view the block from the wedge, we have to add a pseudo force on this in leftward direction. Ma. Alright. Now I write down the Newton's law equation of this block with respect to wedge down the incline. So what do you write? mg sine 60 degree plus ma cos 60 degree minus t is mb. This is the first equation. Okay, fine. Now I write down the combined equation of motion of wedge plus block in this direction. Okay, fine. Now this I'll rub this one, okay? I'll rub this one. Now, in the combined equation of motion of wedge plus block, the combined equation has to be written with respect to ground frame. Only real external forces will appear on the system. There will be no internal forces, there will be no pseudo forces. So, just to draw this combined, write down the combined equation of wedge plus block in this direction, I'll draw the individual free body of wedge and block with respect to ground. Why with respect to ground? Because as I've said just previously also I've said in 19th video of Newton's laws, where combined equation of motion theory has been fully discussed. There I've already stated that we write down the combined equation in ground frame. Only real force, real external forces appear, no pseudo forces. So see, what is the free body of this M with respect to ground? Here we drew the free body of M with respect to wedge, but here we are drawing with respect to ground. This mg, this is T, this is N. Only real forces will act when you see it from ground frame. Now I draw the free body of this wedge with respect to ground. What are the forces on wedge? 4mg. When N acts on this block by Newton's third law, ground exerts a normal force N1 on the wedge. Okay, fine. And what else? This string exerts a force T on the wedge in rightward direction. This one. This pulley is rigidly attached to the wedge. Pulley I take it to be the part of the wedge. So, string will act on this pulley at effectively 2 points. This point and this point. So, one point acts the highest point of pulley T. Another point acts here T, like this. Okay, fine. So these are the respective free bodies of block and wedge with respect to ground. Okay, fine. Now see, in the system wedge plus block, which are the internal forces? T and T are internal forces. So they are gone, they will not appear in combined equation. This N and N, they are also internal forces. This N and N are internal forces, they also go away. They will not appear in the combined equation. In combined equation, they will not appear. Now, only what are the external forces? This one, this one, this one, and this one, and this one. That's all. These are the only external forces. So one thing here T will not act in this way. It will act down the incline. Sorry. Here I have shown you slightly. T is like this. Where this angle is theta at some time. Okay. This T should not, at mistake I drew it that way. It is in this way. and instead of theta naught it becomes theta at some arbitrary instant. Okay, fine. Now external forces on wedge plus block are what? Mg, N1, 4mg, T and T. These are the only external forces. Now we have to write down the combined equation of motion of wedge plus block in this direction. Okay, so I'll write this one also. I'll write this also, okay? So if you solve such types of problems, then you will gain very much confidence, speed and accuracy. It is necessary to solve such kind of problem to excel in JEE Advanced. So someone might say that such questions are not asked. No, it is not that. If you solve, you are going to benefit. That is guaranteed. Okay, I'll write this equation here. Fine. I rub this one. So, in the combined equation of motion of this plus this in this direction, external forces only are T and T cos theta. They do not have, these vertical forces do not have any component in rightward direction. So it becomes T plus T cos theta. Alright. That is equals to summation of mass times acceleration of wedge 4ma plus acceleration of block B with respect to ground in this direction. Okay, so let's call this direction to be x direction. Block has been labeled as B. So I'll write down the name of the term here. M times ABGX. What does ABGX mean? X component of acceleration of block B with respect to ground. Okay, fine. So we get T plus T cos theta is equal to 4ma plus n times. Now what do you write this? ABGX will be written as what? ABG dot I hat. Alright. So it becomes how much? T plus T cos theta. This is I hat is unit vector along x direction. ABG is the acceleration vector of block B with respect to ground. Alright. Now what do I write here? This I write as ABW, W for wedge, plus ABWG dot I hat. Alright. So I write T plus T cos theta is equal to 4ma plus n times. What about ABW? Acceleration of block with respect to wedge, which is nothing but vector being down the incline. So I write it as vector B. And AWG is what? Acceleration of wedge with respect to ground, which is vector A in rightward direction. So vector A dot I hat. Alright. Now simplify this equation here. So what do I get? I have this. Okay, fine. See, by solving such questions, one thing you must note. If you solve only one question of this type, from this single equation we can get 20 to 30 objective problems can come. From this single problem we can frame 20 to 30 different objective questions. So it's very important that you solve such class of problems for gaining speed, accuracy and confidence. So I will simplify it here. So T plus T cos theta is equal to 4ma plus n times, what is B dot? This will break by distributive law. B dot I hat plus A dot I hat. So we get T plus T cos theta is equal to 4ma. Now what about B dot I hat? I hat is in this direction, B is in this direction. Angle is how much? 120 degree. So B dot I hat becomes B into 1 into cos 120, which is minus half. And A dot I becomes A into 1 into cos 0 degree. So we get T plus T cos theta is equal to 4ma A minus B by 2. Alright, fine. I love this one, okay. So when I simplify this, this is plus I missed here. Plus I missed here. 4ma plus I missed. Plus I have missed. I have written it down. Okay. So it becomes T plus T cos theta is equal to 5ma minus, here ma also minus mb by 2. Okay. So this is the second equation. I write it here. So t plus t cos theta is equal to 5ma minus mb by 2. This is the second equation. Okay. So t plus t cos theta is equal to 5ma minus mb by 2. This is the second equation. Alright. Fine. Now count the number of unknowns. A, B and T. 3 unknowns are there. So we need 3 equations. 2 equations we have obtained from Newton's law. Now we have to obtain one more equation. For that, what we do? We write down the constraint equation. Now rub this one. See, constraint equation when we have to write, we must take into account the following fact. That during the course of motion, this theta changes. It doesn't remain theta not always. As I stated previously in this video itself, as time passes by, this angle goes on increasing. So there are variable angle in the problem. So in this case, constraint relation for displacement, velocity and acceleration will not be same. But constraint relation for displacement and velocity will still have the same format. But a constraint relation for acceleration will be different from that of velocity and displacement. So in order to write down the constraint relation, let us first write down the constraint relation for displacement. Okay, constraint relation for what? Displacement. All right. So let us assume that this has been displaced, saying time t to t plus dt. This gets displaced by say dx1, dx. All right, with respect to ground, and this gets displaced by what? dl with respect to wedge in time t to t plus dt. In time t to t plus dt, this wedge gets displaced rightward by amount dx with respect to ground, and in time t to t plus dt, this block gets displaced by dl down the incline with respect to wedge. So we write down the constraint equation at that instant. Now constraint relation is the consequence of the fact that length of string is constant. Length of string is constant in any frame of reference. So we can write down the constraint equation in any frame of reference. So in this case, I'll not write down the constraint equation in ground frame, but I'll write down the constraint equation in the frame of wedge. Okay, to demonstrate the essential concepts of the constraint theory. So we'll write down constraint relation for displacement with respect to wedge. So, and this constraint relation is a consequence of the fact that length of string is constant. Now see, this is a string. Okay. Now see, this string is in contact with wedge at this point. It is in contact with this pulley at this much portion. Equivalently, we will say that this string exerts force on the pulley at only 2 points. At the lowest point T in this side, and at this point T in this side. Now this string acts on this pulley at 2 points effectively, at this point like this, and at this point in like this direction. And on this block T acts in this direction. Okay. Now we will write down the constraint relation for displacement with respect to wedge. Force dot displacement is work done. We have to take all the displacements with respect to wedge frame. So we'll start from here. See, T acts in this direction. And with respect to wedge, this point has 0 displacement because this point is fixed with respect to wedge. So we write here T into 0. So T into 0. Now come to this pulley. Now see, this pulley is fixed in ground and wedge is moving rightward by amount dx with respect to ground. So with respect to wedge, this pulley will be moving leftward dx with respect to wedge. So in time t to t plus dt, this pulley will be moving leftward by an amount dx with respect to the wedge. Okay, so T acts on this wedge at 2 points here and here. Alright, fine. So how much is work done by these two string forces on this pulley in wedge frame? T in this way, dx in this way, thus T dx cos 0 degree, that becomes plus T dx. And here T acts in this way, and displacement is, this point is dx with respect to wedge in leftward direction. So T dx cos theta. Here this was theta naught, but I am writing it arbitrary time. So then it is not theta naught, but theta it is. So I'll write it what? Plus T dx cos theta. I suppose it is clear what I have said here. This I am not writing at time 0. I am writing at arbitrary instant, which I have shown it in this diagram itself. Now what come to this point? Here T acts in this point, and with respect to wedge, this has 0 displacement. So plus T into what? 0. Here also this point T acts on the string acts on this pulley at this point, and with respect to wedge, this has 0 displacement. So here also T into 0. plus on this one, on this Tx in this way. With respect to which this is a displacement of dl down the incline. So it becomes T dl cos 180 degree, which is minus 1. Sum of all of them add up to what? 0. Fine. So here we see T into 0 goes away, this also goes away. So what do we get? T into dx into 1 plus cos theta is equal to T dl. Alright, fine. On simplifying, T cancels out. T goes away. So we get dl equal to dx into 1 plus cos theta. This is what we get. So this is the constant relation for displacement at some arbitrary instant. Now this displacement is in time t to t plus dt. This is also the displacement in time t to t plus dt. What time? T to t plus dt. In t to t plus dt, what is the time which has passed by dt? If we divide both the equations with dt, so dl by dt becomes dx by dt 1 plus cos theta. Okay. Now what about dl by dt? It is nothing but the velocity of a block with respect to wedge. It is the velocity of block with respect to wedge. So let's call it as VBW. Velocity of block with respect to wedge, this quantity. And what is dx by dt? It is the velocity of wedge with respect to ground. VWG 1 plus cos theta. Again you see in this equation, constant relation for displacement and velocity of identical format. Just replace dl by VBW and dx by VWG. We get the constant relation for velocity. So again, constant relation for displacement and velocity have identical formats. But now we have to write down the constant equation for acceleration. So what I do, this I differentiate again with respect to time. So if we differentiate that with respect to time, what do we say? What do we get? dVBW by dt. Okay, fine. Equal to d by dt of VWG 1 plus cos theta. Fine, alright. Now rub this one. Rub this one, okay. Now derivate this. So this quantity becomes acceleration of block with respect to wedge, which is simply b. dVBW by dt. VBW meaning acceleration of block with respect to wedge. d by dt of this b. Acceleration of block with respect to wedge. Equal to. Now this I differentiate using the product rule of calculus. So it becomes dVWG by dt into 1 plus cos theta plus VWG d by dt 1 plus what? Cos theta. Alright. Now we get b is equal to what? B is equal to, this becomes what? dVWG by dt becomes a. Acceleration of wedge with respect to ground. So it becomes a into 1 plus cos theta. Now this term becomes what? Plus VWG d by dt of 1, 0. Derivative of constant is 0. And d by dt of cos theta. That becomes d by dt of what? Cos theta. Alright. So we get b is equal to a into 1 plus cos theta VWG. We differentiate using product chain rule. D by d theta of cos theta into d theta by dt. Okay. So we get b is equal to a into 1 plus cos theta plus VWG. What about d by d theta of cos theta? Minus sin theta. What about d theta by dt omega? Angular speed of the string at time t with respect to ground. Okay. So this is the constant relation for acceleration. So note again that constant relation for displacement velocity are still the same in format, but constant relation for acceleration is different in format from that of displacement and velocity. Now this is at arbitrary instant, okay, where omega is d theta by dt at some time t. Now we have to solve these equations. Now we have to find a at arbitrary instant, so b has to be removed. So what I'll do, I'll put this b here and this t I'll eliminate in this. So from this equation you see what is t. T will be equal to what? Ng root 3 by 2 plus ma minus mb. This is equal to t. This t I substitute in this equation. This t I substitute in this equation. So t into 1 plus cos theta. 1 plus cos theta into t. The 1 plus cos theta is common, and this t I'll put in this one. ma plus mg root 3 by 2 minus mb. Okay, fine. Is equal to 5ma is equal to 5ma minus mb by 2. Alright, fine. Alright. Now I'll simplify this equation. So this 1 plus cos theta into, I'll simplify it. 1 plus cos theta into mg root 3 by 2. Okay. 1 plus cos theta into mg root 3 by 2. Plus 1 plus cos theta I shift to that side. How much will it be? It will be equal to 5ma minus mb by 2. And 1 plus cos theta mg root 3 by 2 is this much. And remaining term I shift on that side. That becomes how much? M into b minus a into 1 plus cos theta. I hope it is properly solved. Is it clear what I have done? Is it clear? So what do we get here? 1 plus cos theta, 1 plus cos theta, this one here into t. T is from this equation I get this t is equal to 5ma minus mb by 2. So 1 plus cos theta into mg root 3 by 2 is equal to 5ma minus mb by 2 plus m times b minus a into 1 plus cos theta. Alright, fine. Now you see m will go away. You can note this point. M just goes away. Alright. Now I substitute this b in this equation. This b I substitute in this equation. Okay, fine. Alright. This I rub it now. This also rub it now. Okay. So this b I put in this equation. So how much do I get? 1 plus cos theta into g root 3 by 2. That is equal to, now this becomes what? 5a minus b by 2. This we are right here. 5a minus b by 2 plus b minus a 1 plus cos theta. Now what is b minus a from this equation? Instead of b I substitute in this b I place here. So this b becomes a plus a cos theta minus omega vwg sin theta. Okay, a plus a cos theta, a plus a cos theta minus omega vg sin theta. This is b, but here it is minus a also, minus a into 1 plus cos theta. So this is the equation. See, 1 plus cos theta into mg, 1 plus cos theta into g root 3 by 2 is equal to 5a minus b by 2 plus b minus a cos theta, 1 plus cos theta. B minus a becomes this b I substitute here. A plus a cos theta minus omega vwg sin theta. Minus a. Okay. Now here this a and you will go away. You can see it. Fine. Alright. So what do we get? See. 1 plus cos theta into g root 3 by 2. Okay. Now what do we get here? 5a. Again this b I substitute here. B by 2. So it becomes how much? A by 2 1 plus cos theta. This becomes b by 2. B by 2 becomes a by 2. I'll write it here, okay? This I'll write to just once again, I'll write. Just to simplify the answer. What do we get? 1 plus cos theta g root 3 by 2. That is equal to 5a minus half. For this b I substitute b here. A plus a cos theta minus omega vwg sin theta. Omega vwg kya? Sin theta. Okay. Plus this a goes away. What do we get? This here we get this a cos theta minus omega vwg sin theta into 1 plus cos theta. Okay, fine. All right. So now I rub that. Okay. Okay. Now here I take a common, and omega I bring to this side. Omega term I bring to this side. Okay. So what do we get? G root 3 by 2 into 1 plus cos theta. Okay. This omega I bring on this side. This will become minus plus it comes here, the minus it will become minus omega VWG by 2 sin theta. Omega VWG by 2 into sin theta. Okay. And here also there is one omega VWG sin theta. I bring it this side. This side I bring it. Plus omega VWG into sin theta into 1 plus cos theta. Okay, fine. So this becomes G root 3 by 2 1 plus cos theta minus omega VWG sin theta by 2 plus omega VWG sin theta 1 plus cos theta is equal to, now we get only a terms containing a on right side. A I take common. So I get what? 5 minus 1 by 2 minus 1 by 2 cos theta. 1 by 2 cos theta, okay. And here also a I take common. This is how much? A cos theta into 1 plus cos theta. Cos theta into 1 plus cos theta. See, this is the answer for A at arbitrary time instant. So from this I see that A will be written as what? G root 3 by 2 1 plus cos theta, and this term becomes what? Omega VWG sin theta. It becomes 1 plus cos theta minus half upon this quantity. 5 minus half becomes 9 by 2 minus half cos theta into 1 plus cos theta. See, this is the expression for A as a function of time. This is what we are asked to find out at some arbitrary instant. Now from this equation it was also asked to find the initial value of A when just after the system has been released from rest. So just after the system is released from rest, just after the system is released from rest, omega is 0, angular speed of string is 0, and VWG, velocity of wedge with respect to ground, that is also 0. So omega 0, VWG 0. So this term goes away totally. And theta becomes theta naught, that is just equal to 30 degree. So here what we do, we replace omega and VWG by 0 and replace theta by 30 degree, that is theta naught. Then we get the initial value of A. Alright. Fine. So rub this one now. So what do we get here? So we get initial value of A is this. Initial value of A, it becomes what? G root 3 by 2, 1 plus cos theta naught, root 3 by 2. This term goes away totally because omega is 0, VWG is 0, this term goes away. Upon 9 by 2 minus half root 3 by 2 cos 30 degree. And here also it becomes what? Plus root 3 by 2 into 1 plus root 3 by 2. Okay. So this becomes how much? G root 3 by 2 1 plus root 3 by 2. This becomes how much? This becomes, let's simplify it slightly. This becomes how much? This becomes G root 3 1 plus root 3 by 2. 2 I bring here. 9 minus root 3 by 2. Root 3 into 1 plus root 3 by 2. This is the required value of A at the initial instant. I rub this one now, okay? So, initial value of A becomes this much. G root 3 I put inside. Root 3 plus root 3 becomes 3. 3 by 2. Here it becomes 9 minus root 3 by 2. Here it becomes root 3 into 1 becomes root 3. And root 3 into root 3 becomes 3. 3 by 2. Okay. So this becomes G 3 by 2 plus root 3 upon 9 plus 3 by 2 becomes 21 by 2 plus this becomes root 3 by 2. So this is therefore the required answer. If you want, you can simplify it still further. You want to simplify. So multiply up and down by 2. 3 plus 2 root 3 upon 21 plus root 3 is therefore the required answer. Okay, you can simplify it still further. You can cancel out root 3 or let it remain like that. That's no problem. Okay, so this also I have demonstrated this concept. So in this I have shown that the constraint relation for velocity and displacement always have the identical format. But constraint relation for acceleration has a different format from that of displacement and velocity when they have variable angles in the given problem. See, one thing I'd like to say, when you go through this problem, some doubts can come in your mind. First thing that if there's doubt, you write in the comment box. I'll clarify it. One more thing, if you have some more doubts in this chapter, what you do, you repeatedly go through these videos, previous videos and this video, repeatedly go through them. Then your concept, some doubts will be dispelled. They'll go away. But still, if you have some doubts, you write in the comment box. I'll explain it. All right. So this also I've completed. All right. So next video again, I'll make a similar problem similar to this question. See, aim is that if you solve such kind of problem, you get confidence, accuracy and speed, which is very needed, which is very much needed in especially JEE Advanced. Even JEE means you need a very large amount of speed you need. Then only you can score good marks, good percentile marks in that 3 hours time. Okay, so you must solve such kinds of problems. If you solve such kind of problem, you are going to benefit from it greatly. Okay, and from one such problem you can get 20 new objective problems can be created. Okay, so this I close it here.